about how rocks are made or why there's so many different kinds? Well, let's think about it. Let's pretend this crayon is a rock at the surface of the earth. So what happens to a rock at the surface of the earth? Wind, rain, all sorts of things are beating down on this rock. There's actually areas in the world where the wind blows so hard and for so long that it shapes the rocks and smooths and polishes them. Those are called ventifacts. That's a kind of mechanical weathering. There's another kind of weathering called chemical weathering. And that's, you can imagine if you've ever been to a graveyard and you see old headstones and you can barely read what's written on there, that's usually because of chemical weathering. Certain types of rocks, like limestones, will dissolve in rainwater. And so that causes different chemical reactions, which makes the rocks dissolve away. So chemical weathering and mechanical weathering. We're gonna show some mechanical weathering on our rock on the surface with this potato peeler. So I'm peeling it off into these little tiny pieces. This would be like animals burrowing around or digging, wind and rain. This could also be the action of trees. Trees go really slow, they grow real slow, but they're very, very strong. And so the roots can actually break rocks apart. So that's mechanical weathering. I did some mechanical weathering on different colored crayons earlier. So you have all of these sediments. They get carried around by wind blowing them, by the water blowing them around. So let's look at a little diagram. Here's where we are, a rock at the surface of the earth, and then weathering, which are these products. Weathering causes erosion, so this has been eroded. It gets deposited in a certain place, which means it's carried by wind or carried by water and deposited, maybe in a valley, maybe in a riverbed, maybe in the ocean, and eventually something happens to it. It either gets buried, and gets a lot of pressure on top of it, which causes it to get compacted and turn into a sedimentary rock. So we're gonna make this into a sedimentary rock by applying some pressure. I'm gonna hold this up into a little boat, okay? And now I'm gonna apply some pressure. Are you ready? Applying pressure to make a sedimentary rock. Okay, now let's see. Let's see what's in here and what it looks like. You can sit down and watch, little guy. Oh, I'm so glad the gardener's here. Oh, look. Look at this. See how it's all stuck together now? That's a process called compaction. This can also happen with cementation. Remember how we talked about the chemical weathering? The stuff that weathers away in the water can actually get down in between the grains and cause it to be cemented together. So this is a process called lithification. So now what we're gonna do, if we look at this diagram really quickly, here are rocks at the surface of the earth, and then they have erosion. They get transported to different places as sediment, then they get deposited. Then they get buried and compacted and turn into sedimentary rocks. If they get carried down deeper into the earth, what happens is they get changed by more heat and more pressure. So we're gonna take our little boat right here and we're gonna put it in hot water. And that hot water is gonna help to melt it a little bit. Let's see what happens. Oh, come here. Can you zoom in a little bit? See how the rocks, in this case the crayons, see how they're melting in different places? They're melting all together. So when you have rocks that get carried down, like in a subduction zone, do you remember a couple of weeks ago we talked about subduction zones? That's where you have one tectonic plate diving down underneath another. It has heat and pressure. I'm gonna try and get more of the rock in contact with the hot water. See that in there, how that's melting? Oh, I don't want the water in there. Although that's an important point. Water is critical for the next stage. So now we have a metamorphic rock. If we let it keep getting hotter and hotter, and we add a little bit of water, it will actually melt. And once it melts, it becomes magma. And so we're gonna let this sit here and melt for a minute. This is gonna turn into our magma. So what happens with the magma, once it's underneath the ground as a melt, one of two things can happen, or two of two things, I guess. It can either cool really slowly underneath the ground and turn into a rock like this. See this countertop? This is an igneous rock. See how there's really big crystals? That means that this rock cooled very slowly and gave those crystals a long time to grow. So this is an intrusive igneous rock. Now, you can also have extrusive igneous rocks. What do you think an extrusive igneous rock might be? Volcanic eruptions. So when you see rocks coming out of a volcano, often the crystals there are going to be really, really small. You're not going to be able to see them the same way that you can see these big crystals. So let's look at another example of an igneous rock. This is called a pegmatite. See how you can see these big crystals in here? This one is from Paula, California. Let's look at the difference between that and these sedimentary rocks. See how this sedimentary rock has layers? Can you see those layers? You know how I said things get deposited? You can imagine one layer of sand or mud gets deposited and then another, and then another, and then another. And we can still see those layers. A really cool thing is that not all sedimentary rocks are made just of rocks. So if you look at this sedimentary rock, this is actually made of both rocks and shells. All right, so let's look really quickly at look at our igneous rock here. See the way it's cooling? I take it out, it's gonna cool, and we'll see that all of these things have run together. So this rock cycle happens over and over again. You have a rock at the surface that weathers, then it erodes, it's deposited, it can get compacted or cemented with lithification, and then it could be uplifted and come to the surface again. Or it can get deeper inside the earth where heat and pressure change it into a metamorphic rock, and then it could be uplifted again and be at the surface. Or it can keep going deeper into the ground. It could get really hot, have a lot of pressure, and combine with water, and then it would either be an intrusive crystalline igneous rock or an extrusive rock, like a volcanic eruption sort of rock, and then everything ends up at the surface again. All right, so that's the rock cycle. I'll put some more things that you can learn about in the comments. If you have any questions, let me know. And hey, if you find a rock this week and want to show it to me, feel free to post it either in the comments or on my page, and we can talk about what it is, what kind of rock it might be, and how we know that sort of thing. So see you next week. Thank you.
Say bye-bye.
Say bye, Ro.